Hello, today we're going to practice taking the MSTEP, the Michigan State Testing of Educational Progress. We'll be doing this later in the spring, and at this link we click here to sign in. And when we go to sign in, it says username preview, so PREVIEW, and then test 1234 is the password. Now that's just for this practice assessment. Later in the next month, they may add in some other examples of questions for us. Welcome training student, confirm our profile, spring summative preview, student session. They've given us a UIC and a district UIC, but we actually have those exact numbers the system will have for you. We select continue. The following tests have been scheduled for training student. Once instructed, once instructed, click on the test link below to start the test. If no additional tests are available, please select exit to close this application. So we're going to do spring 15 preview. Welcome to the early preview. It's to provide us some information, a brief look at the technology enhanced item types. They are likely to be that we may see in the ELA and the mathematics MSTEP. Students will also have the opportunity to use the navigation tools and features of the online delivery system or engine. Students may log into the early preview as often as they like. Look for grade and content specific previews in January. So we're going to begin the assessment. Let's just take a look at some of what we see on the screen. This is what the screen should look like come when we take the actual MSTEP. And it has the question number. If we click on this drop down box, it shows all the questions that are in this section. And this here is the pointer tool. Here is the cross off. If we were going to cross off information, if we click them, they turn the tools all. This is the highlighter, and this is the sticky note tool, and the magnifier if we wanted to magnify the screen, but that would be like if we had trouble seeing. Line guide. If we click the line guide, it comes over here and it puts up a line guide to help us keep track. But we're just going to turn our pointer back on, turn the line guide off. Some letters of the alphabet are shown below. We look at them, I, B, L, F. Which letters have two lines of symmetry? Well, that is if we know things about symmetry. If you've had instruction in symmetry, lines of symmetry would be if you drew a line through a letter and if you folded it, it would mirror each side. And so on this, the B, it does not have two lines of symmetry. It only has one line of symmetry. The L doesn't have a line of symmetry, and the F doesn't have a line of symmetry, but this one right here, you could draw a line right down here and it would mirror each side, and this one, draw a line across here, mirror each side. And it says practice int. Press the cross off button to turn on the cross off button tool. Use the cross off button tool to cross off incorrect answer choices. So if we try this, let's see if it works. It doesn't appear to be working for me. So we'll turn that back off, but we believe this one is the correct answer. So we're going to go down here and click. When we move the pointer down here, it turns into a pencil. Click A, and then we're going to click next. We have the same tools up above. If we look down here, there are some things we can review and in test. We can pause a test. We can flag a certain question and come back and complete it later. But the best method to do is probably to take each question and spend your time on each question, making your best choices, reading and rereading very carefully the questions so that you understand them the best you possibly can. Rick throws 3 model planes into the air. He measures the distance in feet that each plane travels. The bar graph below shows the distance each plane traveled. It's important that we understand the story prompt that we have here. And this boy is throwing 3 model airplanes into the air. And he measures the distance. And here we have a graph, a bar graph, labeled the distance in feet on this axis. Title here, model plane flights, and there's 3 that he named. And the question or further direction is write in the box how much farther Big Ben flew than Swift. Hint, press the sticky note button to turn on the sticky note tool Use the sticky note tool to place a sticky note next to the graph to take notes. And if we take this here, we're going to add a new sticky note. We're going to put one right here. And we'll put it over here. And we could take a note if we wanted to type in, he threw 3 planes and made them. He measured each flight. And if we look at this here, Big Ben traveled 5, 10, 15, 20, 25 feet. Big Ben, 25 feet. I'm taking these notes to help me understand the problem. The Falcon flew 10 feet, and the Swift flew how many feet? Here we go. 5, 10, 15. See, these go up by tens, but so this is a 5. Each one of these increments, or these lines here, are at 5, 10, 15, 20. So the Swift flew 15 feet. Now, write in the box how much farther the Big Ben flew than Swift. Here's Big Ben, here's Swift. If we look we're finding the difference is what we're doing. We could use subtraction. This would be a strategy. 25 minus 15, or the distance from here to here on the graph, that represents 5, 10. So really, they flew the difference of 10 feet. And I clicked the pointer in here, then I typed in 10 feet. Notice down here it says numeric only. So I should not write feet in here because feet is already written here for me. So only put numbers in there, and I've done that. And I think it's done, so I'm ready to go on to the next problem. You'll notice that I'm taking quite a bit of problem on each problem. And it will take time to do your work on the MSTEP. Lars is finding, once again, we have the same buttons that we have before, but we have different prompts. And we may have different tools that we will use. Lars, that's the name of a boy, is finding different types of minerals. The table below shows how many minerals he finds. Let's look at the table. Minerals found, type of mineral, K-spar, mica, quartz, zinc, and the number found, the number of minerals he found. I guess these would be either the flakes of the minerals and the rocks, or maybe the stones or rocks that he was finding in his collection. Click to make the bar graph show the total number of each kind of mineral Lars finds. Hint, point on the graph to make the bar heights. Well, if we look here, it says K-spar is 4, and we come over here to this graph, minerals found, number found, and we have K-spar. How many did he find? Number found 4, so let's click here. Oh, look, if I start clicking here, it builds it for me. And I want to go up to what? To 4. If I go too high, I can get the eraser up here and erase the whole thing and start over again. Get my pointer again. 1, 2, 3, 4, and then mica is 2, and then quartz is 8. If we just go all the way up here, see the 8, follow this over. There we go, went up really fast there. Zinc is a 6. And we come up to here, and then we can check our work. 4, 2 for mica, look back to the left. 8 for quartz, look back to the left. And zinc 6. I do believe this is correct, so we could go on to next. If we made a mistake, we could click erase. Look, it says reset all. If I push that, it would erase all of them. Okay, so let's go on. Now we have a fraction one. Now, if you're in 3rd grade, this one here it may be far too hard for you, but our 5th graders and 4th graders very well could see problems like this. Match each fraction below with the model or models showing an equal fraction of shaded bars. Excuse me. Practice hint. Select a fraction on the left side of the blue box, then select its match on the right side. A blue line connects. Some fractions may have no matches and some may have more than one. To undo the last match, press the undo button, which is one of these. Undo, redo. To undo all of the matches, press the eraser button. So I want to look at my fraction strips over here. This is 1, 2, 3, 4, 5. So this is 1/5. This is 2, and there's 8 total. So 2/8. And some of you know that 2/8 is equal to 1/4. There's 1/4, 2/4, 3/4, 4/4, because some fractions can be equivalent. Excuse me. Let's try to select one here. Once we find one that lines up, 2/8, this would be the 2/8 right here. So if I click 2/8 and made it blue, then click here, that's 2/8. Okay. This one here is 1/3, but some of us know if we drew a line through here, we would change this to 1/6 instead of just thirds, and that would be 2/6. So this one here does go with this one. Obviously, to do well in this problem, you need to understand fractions. And your teachers have been teaching you about fractions since first grade, but equivalent fractions you start seeing in fourth and fifth grade, some in third. 1/4 is another choice. And if we look over here, 1/4, 2/4, 3/4, 4/4. So 1/4 is pictured right on this one also. And it did tell us up here that we could have more than one answer. This is not easy work, boys and girls. It takes time to look at it carefully and think about all of the options. Read and reread the directions again and again as necessary to help you understand. One of the strongest strategies for doing a problem is, if you don't understand, reread. And then here we have 3/6. 3/6 is equal to 1/2 of a, 3/6 of a pi is the same thing as 1/2 of a pi. But notice when you look over here, what do we see? We see 8s, 2/8. This is 4/8. 4/8 of the whole, but actually 3/6 and 4/8 are really equal. If we would take this and divide this up into thirds or sixth parts, I would get 3/6. This line would line up with the same as 4/8. Now, we look here, I don't think we have any fraction that lines up with this one. Now, as teachers are looking at this, maybe I've made a mistake. If so, boys and girls, talk to your teacher about it and find out a better answer. I think this is correct, so we're going to continue. A scientist is finding the mass of food to list on packaging. A box of pasta has a mass of 400 grams. When rounded to the nearest 100, choose all the boxes that could be the mass of the box of pasta. Mass is a science word, and if I could click this on, I could add a sticky note down here. Mass is actually the amount of matter in an object, and it is relative to weight. It's not exactly the same, but it helps us understand when we're looking at grams of weight in a box of cereal or a box of pasta in this case. So the question is asking, and once again, the question is asking, we can reread to really understand. They want us to find the mass of food. They're finding the mass of food in the packaging. A box of pasta has a mass of 400 grams. That is relative to weight. When rounded to the nearest 100, they want us to choose all the boxes that could be the mass of box of pasta if we would round it off to the nearest 100. Because we're dealing with 400, that means we would, we're either going to round it off to 300, 400, 500, but we're rounding off to 400. So if we know our rounding off strategies, 480 rounded off to the nearest 100 would be 500, because we look at this digit, the digit to the right. If it's 5 or higher, we round up. If it's 5, if it's less than 5, we round down. So 4/8, that wouldn't work. And the suggestion is use the pointer tool to choose all the correct answer. 362 would round up to 400, so that one would work, and we click it and it lights up. 320 would round down to 300. 454 would round up to 500, and 435 would round down to 400. So I've selected the two that would round off to the nearest 100 of 400 grams. I think I have this one correct, so let's go on. And that's all the time we have for the recording at this time. We'll add some more on later.